You ask ChatGPT a question, and 3 seconds later, it spits out a perfectly coherent answer. But here's what's actually happening in those 3 seconds that nobody talks about. ChatGPT doesn't understand your question. It doesn't think about the answer. It doesn't even know what words mean. Instead, it's performing a mathematical trick so sophisticated that it accidentally looks like intelligence. And when you understand how this trick works, you'll never look at AI the same way again. Let's start with what ChatGPT actually is, because the name itself is a clue. GPT stands for Generative Pre-trained Transformer. Each word matters here. Generative means it creates new text rather than just finding existing text. Pre-trained means it learned patterns from massive amounts of text before you ever talk to it. And transformer, that's the key piece we need to understand. Think of the transformer like an incredibly sophisticated autocomplete system. You know how your phone tries to predict your next word? This is like that, but instead of just looking at the last few words, it's considering relationships between every single word in your entire conversation. And it's doing this while filtering everything through patterns it learned from basically the entire internet. Here's the insight that changes everything. ChatGPT doesn't work with words, it works with numbers. When you type, "What is photosynthesis?" ChatGPT immediately converts each piece of that sentence into what are called tokens. Think of them as the fundamental units the model processes. Each token gets mapped to a specific set of numbers called embeddings. The word photosynthesis becomes a specific list of numbers. The word what becomes a different list of numbers. Even the question mark becomes numbers. Why numbers? Because you can't do algebra on the word cat, but you can do algebra on the numbers that represent cat. Once everything is numbers, ChatGPT can use mathematical operations to find patterns and connections that would be impossible to program directly. But here's what's wild. These numbers aren't random. Through training, ChatGPT learned that words with similar meanings should have similar numbers. So the numbers for car and automobile end up close together in this mathematical space, while car and elephant end up far apart. The system discovered these relationships automatically by processing billions of examples of human text. Now let's walk through exactly what happens when you ask ChatGPT a question. Say you type, "Why do leaves change color in fall?" Step 1. Your sentence gets chopped up into tokens. Not just words, pieces of words, punctuation, even spaces. Why becomes one token, leaves becomes another. Sometimes one word is one token. Sometimes part of a word is one token. The system learned the most efficient way to break up language during training. Step 2. Each token gets converted into a vector, a list of hundreds or thousands of numbers. Think of this like giving each word a precise location in a vast mathematical landscape that's impossible to visualize but perfectly real to the computer. Step 3. Here's where the magic happens. The transformer uses something called attention to figure out which tokens should pay attention to which other tokens. When it processes the word leaves, it needs to figure out, are we talking about leaves as in tree leaves, or leaves as in someone leaves the room? The attention mechanism looks at all the other words in your sentence, change, color, fall, and realizes we're talking about tree leaves, but attention works in both directions. Every word is simultaneously listening to every other word and adjusting its meaning accordingly. It's like having a conversation where each word is constantly asking all the other words, "Hey, what do you think I mean in this context?" Step 4. This attention-weighted information flows through multiple layers. Modern models have dozens of them. Each layer refines the understanding. Early layers might figure out basic grammar. Middle layers might understand that this is a question about biology. Later layers connect it to concepts about chlorophyll and seasonal changes. Step 5. Finally, ChatGPT predicts the most likely next token. It looks at all the mathematical relationships it just computed and calculates. Given everything I understand about this conversation, what should come next? It might predict leaves with 47% probability, trees with 23% probability, in with 15% probability. Here's the crucial part. ChatGPT picks one token based on these probabilities, adds it to the conversation, and then repeats the entire process. It recalculates attention, flows through all the layers again, and predicts the next token. So when ChatGPT says leaves change color in fall because chlorophyll breaks down, it didn't plan that sentence. It predicted leaves, then given leaves it predicted change, then given leaves change it predicted color. Each word emerges from the mathematical relationships the model learned during training. But here's where it gets more complicated. What I just described is actually the simple version. The real ChatGPT you interact with went through 3 distinct training phases, and each one changes how it behaves. Phase 1 was pre-training. OpenAI fed the model hundreds of billions of words from books, websites, academic papers, forums, a huge chunk of human-written knowledge. The model learned to predict the next word by processing all these examples. It wasn't trying to be helpful or safe. It was just learning the statistical patterns of human language. The result? A model that could complete text but not necessarily in useful ways. Ask it, "How do I bake a cake?" And it might continue with, "In a nuclear reactor," because it found some weird corner of the internet where someone wrote that as a joke. Phase 2 was supervised fine-tuning. OpenAI hired human trainers to have conversations with the model and demonstrate good responses. If the model gave a weird answer about nuclear cake baking, a human would show it a proper response about flour and eggs and ovens. But even this wasn't enough, because humans are inconsistent. Different trainers might demonstrate different styles, and the model would learn all of them. Phase 3 was reinforcement learning from human feedback, RLHF. Instead of showing the model good responses, humans ranked multiple responses from best to worst. The model learned to predict which responses humans would prefer. It's like having thousands of human judges constantly evaluating the model's answers, and the model learning to optimize for higher scores. This is why ChatGPT tends to be helpful and harmless, not because it was programmed with those values, but because it learned that humans consistently prefer responses with those qualities. But RLHF creates its own problems. The model sometimes becomes overly cautious, refusing to answer perfectly reasonable questions because it learned that humans penalized anything potentially controversial. It might refuse to write a fictional story involving conflict because conflict triggered safety responses. And here's a deeper issue. Nobody fully understands why transformers work so well. We know how they work mechanically. I just walked you through it. But we don't know why this particular approach is so effective at capturing language patterns. When models reach a certain size, they suddenly develop abilities that smaller models lack. GPT-3 could learn new tasks just from examples in your prompt. GPT-4 can understand images and reason through complex problems. We call this emergence, and it's both exciting and concerning because we can't predict when or why it happens. So why does this matter to you? Because you're living through the moment when humanity figured out how to create machines that can manipulate language as fluently as humans. And understanding how they work changes how you should use them. It explains ChatGPT's weird strengths and weaknesses. It's incredibly good at tasks involving language patterns, writing, editing, explaining concepts, translating, even coding. These all involve the same basic skill, predicting what should come next based on learned patterns. But it's terrible at tasks requiring actual reasoning or real-world knowledge that changes over time. It doesn't know what happened yesterday because its training data has a cut-off date. It struggles with counting letters in words because it processes text as tokens, not individual characters. It will confidently tell you Paris is the capital of France, not because it knows geography facts, but because Paris is the capital of France appeared thousands of times in its training data and became a strong statistical association. This changes how you should interact with it. ChatGPT isn't a search engine, it's not a calculator, it's not a fact-checker, it's a language pattern matching system that's incredibly sophisticated at generating human-like text. Use it for tasks where language pattern matching is valuable: brainstorming, editing, explaining complex topics, generating creative content, thinking through problems from different angles. Don't use it when factual accuracy is critical, mathematical precision is required, or you need recent information. And always remember, it's not thinking about your question. It's performing mathematical operations on numerical representations of your words to predict what a helpful human would probably say next. But here's what's remarkable. That mathematical trick is so sophisticated that it often produces genuinely useful, creative, and insightful results. Not because the machine is conscious, but because language itself contains patterns that, when decoded mathematically, reveal deep structures about how humans think and communicate. You're interacting with a mirror of human knowledge, reflected through mathematics, that can generate new combinations of ideas by finding patterns in how humans have expressed similar ideas before. That's not intelligence as we typically understand it, but it's something new and powerful. So the next time you ask ChatGPT a question, remember what's actually happening. Your words become numbers. Those numbers flow through dozens of layers of mathematical transformations, and the system predicts the next most likely token based on patterns learned from hundreds of billions of examples of human text. It does this one token at a time, rebuilding its understanding of the entire conversation with each new word, until it produces a response that feels remarkably human. Not because it thinks like a human, but because it learned to mathematically approximate how humans use language. It's not magic, but it's close enough that the distinction might not matter for how it changes the world.